Hi everybody, my name is Katie Kondo. I'm a 12th grade math teacher at Da Vinci Science, which is a public charter in El Segundo. And I'm here to tell you today about project-based learning. So project-based learning is one of the central practices of our school. So every class in our high school is taught through project-based learning. So most teachers don't have a textbook for their class. I think math is probably the exception to that because we're using the CPM College Preparatory Math Curriculum, which is a inquiry-based collaborative learning kind of model for math, and through it the students do um, problems that help them understand, like help them develop the strategies to do the math problems, and then working through like the applications of it. So we feel like it really aligns very well with project-based learning and kind of really facilitates it in a way that maybe a traditional textbook may not. But so like I said, project-based learning is something that all of our classes are doing. Kids are really used to doing projects now all the time, and that's kind of the main focus of a lot of the concepts that we're learning, is to drive how do we solve this issue that's come up in our project, and how do we utilize math to solve a real world problem. And they really start to understand how like the math that we're learning fits into the world around them, and why it's important, why it's relevant to them, and all of those things. So before I get started at this, I want to front load a little bit by saying our school obviously was not the one who came up with this. So we were looking at the models at a couple of other schools when we first started. This is now the 14th year, no, 12th year of the school. So, and I've been there for 8. So this is, it's, yeah, so it's something that a while back, like when I first started, they had us all go through trainings. And I know that they did for the teachers in the years before I joined. Run by a group called the Buck Institute. So the Buck Institute does all this project-based learning training, and they're the ones that we kind of understood the structure of how projects should run. So starting with a driving question, like that is like going to drive the entire project, and the goal of the driving question is to say, how do we use our content to understand the question, what the question is asking us, right? And then there's a thing called an entry event that's supposed to be kind of like fun and exciting and get the kids like really pulled into the project. And then after that, they really taught us about how to plan a project, how long things should take, like how you build, the structures that you need to build into it. And then at the end of it, how do we assess them? What is the rubric? What should the rubrics look like? What makes a good rubric? What makes one that's not so great? So all of those kinds of things we did a big training on, and then went back to our classrooms and started implementing it. And so I think at the beginning, so just if you're implementing project-based learning at your school, I would say this, and probably actually for the same thing for CPM, when you run these things, they're very different than what a traditional classroom typically looks like. So kids aren't used to it, and it means that, and I wasn't used to it either. So I know that the projects that I developed in the first few years, I try not to think about those too much because they weren't like the rich kind of engaging with content that I really wanted. But it was just because, we just didn't have that much experience with it. So yeah, so we wanted to really focus on projects that, like, because of the kids' interest in the project, would push them to dive deeply into the content that we're learning. So because they feel this urgency to solve the driving question, then that makes them like, oh, well, what else do I need to do? Oh, I need to learn this math concept. So they like figure it out through the whole thing. So rather than doing something, we call it steak versus the sizzle. So you don't want to just like make a beautiful poster or make a beautiful model, because maybe, like, I don't know how much they learn from cutting like a border around, a picture or something like that, but more like, what do we have them create or do that would allow them to really richly engage with the content that we're teaching. So I'm going to show you a few things that I've done. So my first year at Da Vinci, I taught a class that was like basically kind of a algebra 2-ish kind of class, or we were kind of playing around with how our curriculum was structured at the time, or our classes were structured at the time. So yeah, so this one, I feel like the content for this really falls into like a typical algebra 2 class, and I guess you don't necessarily have to have trig involved. I put that in the title, but um, at least for this project. So I'll show you what I usually give the students. So there's typically a packet of sorts that I give them. It's not usually a ton of things, but I try to give them all of the documents all together at the beginning, so there's no like shuffling of papers. It's all in like one spot. So so the project was to write a children's book. um, Conveniently enough, we had two elementary schools that were right next door to us. So what they did with this was that they wrote the idea was that they wrote a children's book, and at the end of the project we'd go to visit the schools and we read the books to first graders in at both of the sites. So that was really a neat thing. And it also creates, you know, like some urgency around it, and you want it to be really good because you don't want to be sharing like a bad book with like a little kid, because they're going to be real honest with you, right? Or not show up with one at all. So so yeah, so the book was had to be a story about something, so whatever they wanted it to be about, totally fine. But basically I told them that the storyline just had to incorporate some kind of growth, either geometric or arithmetic. I think my goal was for them to really understand how exponential growth um, multiplies very quickly, and you start getting really large numbers really fast. So the idea of like slow growth at the beginning and then really like explosive quick growth, you know, at the end. And so which I don't think people realize. And so when they started to compare the books of the kids that were doing like the arithmetic sequences versus the geometric ones, it was really interesting because like the kids doing the arithmetic ones didn't have to draw as many pictures, I guess. So you can kind of see the examples along the side. So this is a character from an anime named Naruto. Naruto is has this power where he can like multiply, and so this is him here, and then more and more and more. Same thing with Mickey from or from Sorcerer's Apprentice. So here multiplying the broom. So here 1, 2, and then all of a sudden a lot. So so yeah, so they built out this book. You can see the driving question here. I'm really clear about what the phrase deliverables means. What are you going to have at the end of the project? So is that a book? Is that a model of something? People have done like newspaper articles, or sometimes it's like a debate, and that's the deliverable, is like a debate. Like one of our world history teachers does like a round table where each kid takes on a philosopher that they've learned about, and she asks them questions that the philosophers have to talk about from the perspective of that person. So, you know, things like that. Those are all deliverables, can take any shape or form. It doesn't necessarily have to be something, you know, that you can hold in your hand, but more often than not, it usually is. So, so yeah, and then I usually do a pretty detailed, this is one of my earlier documents, you know, I like made this a year two, first or second year of teaching under project-based learning. So, but yeah, so the details here, it's kind of laying it out. I would highly recommend doing checkpoints. You can't just have like one big due date. Kids need everything super broken down. So by this day, you have this many things, or you have this done, by this day, you have this thing. And then also you can give them feedback along the way. So for example, in this project, the first thing that they had to do was this where it says outline of title page and day 0 through 3. So that was, I think this, well, even before this is not even listed here. I know I did a rough draft of this so that at every step of the way, I could look at their work and give them feedback on it. So that was really important, so that it's kind of, so that it's molding them in the right direction gradually, rather than they turn in something that they've been working on for 2 weeks at the very end and they're like, oh shoot, like I did everything wrong. Like you can catch things really early on, and if you can give feedback, and I can show you how I do that too. There's some pretty good ways to do that, or efficient ways, so we're not grading all day. But yeah, I found that if I can make the time to do the feedback along the way at every checkpoint, or at least at every other checkpoint, the projects themselves turn out so much better, and the kids are generally a lot happier, and they learn more. So, so yeah, so here's the feedback pages that I have them do along the way as well. So peer feedback is definitely a huge part of the work that we do in project-based learning. So this is kind of an outline of things that I thought that they needed to make sure that they have. And after you've been doing these projects for a while, like if you repeat a project, you know kind of the common things to look out for that are really easy to fix. So kids tend to make similar mistakes year to year, like they don't, do easy things. Like in this one, the number of pages or the numbers in the sequence of days needs to be fixed. So like they start on a day 0, but then it's like not the number for day 0, or something really easy that you can like fix pretty easily. So, and kids can check really easily. So that's what I have them do. They all get a chance to share their work currently with each other. We talk about the language of giving feedback. So I really like this. And instead of saying this sucks, like you say, I wonder if blank, blank, blank. And by the time the students have been doing this, even 9th grade, they work a lot on the language of that. Our students are so good at giving feedback that normally I think what might be a very defensive situation where they feel like, oh, I'm sharing my work with like all these people around me and they're giving me negative feedback. They really see it as an opportunity to grow. So we're cultivating a bit of a growth mindset kind of thing too through doing this peer feedback. So there's a lot of protocols for giving peer feedback. We call them critical friends groups. So if you look that up, I would suggest having the students follow a protocol, like 1 minute for the student to share their work, 1 minute for feedback, or 2 minutes for warm feedback, 2 minutes for cool feedback, follow up, those kinds of things. So yeah, so that's that. And then this is the rubric. And I'll show you the new ones that I've done more recently, but this one, we used to have an honors option, and then we just broke things down 4, 3, 2, 1. And you can kind of see how everything's laid out. So this is kind of like borrowed from the Buck Institute format. That being said, most of the teachers at our school have since changed to a different style of rubrics. So I'll show you that. And this is this is a project now that I'm using every year. So one of the classes I get to teach is calculus. So, and this is one of the projects that I do with them in the beginning of the year. So I'll share with you also, let me change my screen real quick, how I launched the project. So we usually have something called an entry event, and this can range from like, I know one of the math teachers a while ago did a project where they were, I think it was in geometry, and they were doing some things with like a chair design basically, and I don't remember what the thing was about, like area or something like that, but basically they had to design some furniture. And so that day the teacher had all of the furniture removed from the classroom, and the kids came in and there was nothing there and nothing to sit on and none of the tables and all of that. So it was kind of like this big deal. We're like, oh, well, furniture is like this really important part of our lives. So how do we make sure that the furniture that we have is really useful, and what do we want in it? And if we got different furniture back, like what would we want it to look like? So it's more like a kind of shock kind of thing to provide something very memorable for them. So, and this one, I feel like my entry event isn't as strong, but the one for the next project I'll share, this one of my favorites. So, so basically this one, I'll show them a bunch of videos of a couple of things so we can contrast like video of an eagle, awesome, but then there's video of an eagle, right? So there's two things happening where one really shows like this one clearly shows a very different perspective on why we might think eagles are interesting. Like I think the second one was much more I don't know, it was really interesting. So I do a few of these. So there's some like bike riding ones. These ones I ended up choosing some like first person perspective things, but the reaction from students in class is really interesting. They normally will, they're watching the first one, they're like, oh, that's cool. And then when they watch this one, they're like, whoa. So they're really into like you can kind of see here, it's pretty dramatic. So what I was trying to get from them is for them to kind of remember the visceral reaction of like watching something like that. And then the question is what kind of image, like the question is how do we take something that you're interested in, find a video that like really demonstrates that. So my sample was for violin playing. So when I was younger, I played the violin. This is kind of how I can share some things about myself with them. So I'm like, this is maybe what a typical orchestra looks like. There's a video with it. But then there's other versions of, that are out there now where people are playing the violin in a different context. Um, something like this that's very different from, the normal violin playing. And I think for me, like playing the violin was super fun. So this more exemplifies why I really enjoyed that when I was younger. Kind of defies like your traditional notions of things and whatnot. So anyways, the project is this. So what they do is they have to pick a 15-second video. And it's an opportunity for them to share something that they're really interested in. So the videos I get have like really cool stories behind them, and like some of them it's like I found out one of my girls was like almost qualified for the Olympics in figure skating. I had no idea, and she showed a video of her figure skating, and that was so neat. So it's a really neat opportunity to kind of get to know the students. The Calc Connection is I have them. What they end up doing is, let me show you that. So these are the slides that I run through with them. But what they end up doing is taking that video and analyzing it on a app on the iPad called Vernier Video Physics. So these are my instructions that I give to them. This is in that packet that I told you about. And they upload the video onto this. And what Vernier Video Physics does, so you have to like be really detailed in the instructions. So I give them time in class to work on this. They, are understanding like how the units work and all of that. But basically what this app does is generates a position and a velocity graph for an object that's in the video. So the students have to choose like an object in the video. So in my video, I tracked the right hand at the bottom right of this violin player, because this is the bow. That's the main thing that kind of controls, how the sound is in the violin. And so then this graph that it generated is a map of the horizontal distance of the violinist's hand away from the left side of the screen. So, and then there's also a velocity graph down here, which is really neat, because then we can start talking about, what does negative velocity mean? What does it mean when this graph goes up and down? How does that correspond to the direction of the object in your video? So we do all of this. They create the graphs. It generates a table as well for them, really trying to get at like, the multiple faces of a function, as our 10th grade math teacher likes to call it. And then, so through a series of checkpoints, you can see they're all labeled now, checkpoint C and D, and the students build out a cover page paragraph about why they chose that video. And then we do a couple of things with it. So with the position graph, I have them, one of the requirements for the video is that their graph has to create a discontinuity in it. So for mine, you can see the gaps in the graph. Where the bow of the violinist goes off screen and can't be tracked anymore, and then comes back on screen at a certain time. So what video physics does is automatically creates a continuous function. So you have to actually go back and like alter the graph yourself. And so that takes a bit of precision work, and the kids have to really figure out like the timing and understand the time of the video correlating to the x-axis, and then the location of the bow or the object that they're tracking corresponding to the y values. That when the graph is going down, that's when the bow is moving closer to the left side of the screen. When the graph is going up, that's when it's moving further. So the connections between like what's physically happening and what they're seeing in the graph become really strong through this whole kind of process. We're talking about continuity, so they have to write out a proof of continuity or discontinuity using the 3 conditions. I have them look at the graph and pick a place where they think the velocity is the fastest and estimate the average velocity. We haven't done the derivative at this point, so they just do average velocity. And then when we get the velocity graph, I have them look at it and say, where do you think the most displacement happened? And like talk about how you can do this area over, a discontinuity in the graph, or kind of visually where do we think that that happens, that it's okay to do it under the axis. So then they do the Riemann sum for the area under this curve. So there's a lot that kind of gets brought in. And at the end of the project, they've built out this document and then they present it to everybody. And yeah, those presentations, you know, this is the outline that I give them. And then the rubric is down here. So you can kind of see that we've adjusted our rubric to only have the 4s and the 3s. Some teachers only do the 4s. So it's because we found that we were just like altering the words. So like, this is excellent, this is good, this is sort of good, this is not good. So, or I mean, we wouldn't use the phrase not good, but like basically that was kind of how the breakdown went. And it didn't really, using it wasn't as functional as I think we thought. So it was better to just say like, what is the standard that we want them to achieve? And that's this. And then whatever falls short, like whatever score you get is a reflection of how much, you know, you haven't gotten to yet. And if they really want like a more detailed breakdown, we have office hours twice a week, 3 times a week. So they will come in and they'll ask us, so we can really sit down and talk with them about it. But that doesn't happen very often. So, so yeah, that's essentially it. I can show you some of the projects that I've had students do, so you can kind of see where they've taken this. So this one is a student who loved doing filming on a drone. So he found a video of it and then analyzed it. You can see his like the styling of this is really interesting, really neat and like very vivid. I really loved how he put this together. But what was really great about it was that essentially like all of his information was, oh, I used to make them do the graphs. I don't do this anymore because situations like this would happen where like most kids would do, you know, 4 or 5 functions, but Angel of course did like 30 or something like that. So you can see like they learn also how to make really clear arguments in math. So a lot of them struggled with like formatting things in a way that makes their reasoning clear, or typing out stuff in a way that makes sense and really shows very clearly where their work comes from. So a lot of my feedback is sometimes focused. I mean, a lot of the times, like it's really about like understanding the math concept behind it, but also there's like a deeper level of understanding that comes from when they have to understand how to lay out their work in a way that will make sense. So like you can see that on this one, like the green correlates with the green in the table. So I know personally that the student has like made that connection between the values in the table and stuff like that. Sometimes it's interesting doing the velocity. They'll pull from the velocity table, and then we talk about how like you're not finding the change in you're not finding the velocity, but you're finding the change in velocity, and that leads to talks about acceleration and things like that. So units are really important. So you can kind of see how like the little details like enable them to really understand motion in a graph and the data that we're getting, and with something that they think is really neat. So because like this is about, you know, his quadcopter. So and then this is the discontinuity argument, the table for the velocity, and then the velocity graph is most area, and then the layout of that and understanding how the delta x's are calculated and all those kinds of things. So so yeah, there's a few others. This is from my students from 2 years ago. You can see kind of it's kind of a different format, but the idea is basically the same. What I really liked about a lot of these students that I'm sharing with you is that their work was so clear, and they really did such an excellent job of like putting their understanding on display. So like I felt like other students could read this and really clearly know where their information came from, right? So like we could look at this, we know the time that he pulled from, we know the units, we understand what he's talking about, and then there's also like connections they can make to the velocity graph and to the position graph about, at least for the position graph, like steepness of the line and then y value of the velocity down here. Doesn't always correlate with this one because this graph at the bottom, the velocity one that Vernier does is a derivative graph, so the doesn't always correspond to the average velocity. But so yeah, so there's this, and you guys can take a look at You know, some of these other ones, I put 4 in here for this one because there were so many that were so good. Um, you know, so you can see how they do the different things, but the students are all like, you know, what I provide for them is just that sample document, and you can see a lot of them formatted kind of similar to mine. A lot of them don't, and that's really neat when they do. You know, if they do it a different way and it comes out really neat, then that's awesome too. So okay, and then the other project I'm going to share with you is called the Optimal College Experience. So this project, they are essentially designing a new college campus. So this one, the entry event for it is I take the project packet with this letter on it, and then I made like a envelope that has like a Euler stamp on it, you know, like a fake postage stamp, and then like addressed to them and whatnot. And we and I fold them up and put them in the envelopes, seal them up. The years that I have a TA, it's so great because they can do that for me. And then I drop them off with the front office, and so our office manager, she knows we do this every year, so she knows she knows what to expect. But but so then they take it to the front office. And then I email her, and then I go to my computer and kind of like pretend like I've gotten an email, and then I'm like, oh, like so strange, like Liz, who's our office manager, like just email me. She said we got like some letters. Can someone go get them? And you know, all the kids like volunteer to go do the errand. So one of them runs to the front, comes back with a basket of letters, and I like act all surprised, and we pass them out. And then so the kids are like, you know, they're seniors, so getting mail, they're like, oh my god, is it a college thing or whatever? And then they open it, and then they're like, oh, it's a new project. But they're so interested, and it, like, as long as I can like kind of play it really well, then they get completely tricked into thinking that they've gotten mail. And yeah, so it's really cute that they, like, you know, a lot of them will keep the envelope and like put it in their binder and stuff like that. So so we pass them out, and then what gets shared with them is this slide that I was showing you earlier. So there's a letter that's in there. You can see that I've kind of made the checkpoint stuff more clear and really broken down. There's due dates over here, and what's gonna do along the way. So basically, what happens is the students will, oops. Okay, so the students will have to choose a building. So that's one of these: this dorm building, the student union, the study lounge, the cafeteria, and they're in a team of 4. It's whatever the team they were working with in CPM, and they have to come up with a college, and based on a theme, and design the rooms and things like that. So let me pull up the slides and I can share with you what that looks like. I think this will make it more clear. Yeah, okay, so this is like what we do on the first day, and this kind of is how I explain the project. So there's the letter, ask them who's been on a college tour, what does it look like, were you so inspired? Okay, here's your chance. Like, you're gonna design a building or a room on a campus. And so this is an actual sample from year 1. So this is, you know, what projects maybe look like starting in the beginning. But then I can start accumulating project samples from students and show them, so they know like what the level of the project needs to be at. So this one got a little bit better, right? So now we're using, we're drawing a little bit more 3-dimensional. There's some explanations of things. And then really, like, what ends up happening, and the best tool to use is this floor planner website. We used to use SketchUp, which is what this one is on, but SketchUp has a high learning curve, or steep learning curve. So they were able to do a lot of cool stuff on it in the years that I used SketchUp, but when Floor Planner came out, like, I think that was the best one to go with. So each team, so you can see this is a team of these 4 students, come out with a design of 4 buildings on a campus. So, and they can be round. In the beginning, it has to be a rectangular prism on the exterior. And so what I tell them is that they have to choose one of these, and then decide on a theme as a team, and then they design this building. The only restriction is that the building that they have, I have like a little raffle. The students will come to the front and they'll pull a volume out of a bucket, and then that volume is what their building has to be throughout the project. So the main concept is, okay, so they get this volume. So their first step in this process is figuring out what the dimensions, you can see down here, of their or of their building will be, and the volumes are all adjusted accordingly. So obviously, like, a dorm room isn't going to come out the same volume as a rec center or something like that. So they all get volumes appropriate to their type of building. But so they decide, and we learn how to solve backwards. They've forgotten that from geometry, how to do the length, width, and height. And so they pick what they want them to be. They calculate the cost of their building based on that length, width, and height they've chosen. And then after that, we build out a cost equation. If I can, yeah, and we build out a cost function for their project, and then the idea being that once we build the cost function, that would be the lowest point on this cost curve, right? Then we do the derivative of that, we set it equal to 0, and then that'll allow us to solve for the length, width, and height of the building at the minimum cost. So this project is like an optimization problem, but just kind of like in a bigger context. So this process, for some reason, seems so kind of basic to calculus, but for students is really hard to remember, and I'm not quite sure why. But like, this really gets at, like, sometimes their dimensions are funny, and like they get a curve that goes upside down, and so we can understand that the derivative also gives you maximums. But really, like, this, I feel like, for them, so super solidifies the concept of the tangent line has a slope of 0, that this is the minimum point, and that we can test the left and the right, and like we kind of get into like first derivative test, second derivative test. Like, here it's concave up, so it's a minimum. The function is decreasing and then increasing, so this point is a minimum for the cost. So they basically go through this, and then after that they figure out how much they've saved off their original building, which is kind of a cool moment. So they usually have saved a good chunk of money. It's usually like upwards of $3 or $4 million. So that's kind of a very dramatic moment where they're like, whoa, like, I didn't think that this was really gonna do that. So yeah, so they run through this. They do a rectangular prism first. They run through the whole process with it, and then they build out one for a cylindrical building. That was the round one that you saw earlier, and then one with a dome roof. But essentially, the process is the same for all of these things. And at the end, they give a presentation with their team. The whole scenario is that from this very beginning, right, is that there's a university called the University of Da Vinci, who is asking them to build a new building, or a new school, so a new student community, I guess. So they come to their presentation as it's like a pitch. So it's not this is my project and this is the math I did, but it's really like, this is how we know for sure that this is the lowest cost, and you guys are getting like this amazing building, but like, we saved this much off of like the original value, the original cost of it, and so you should definitely like this one the best. And so it becomes like a really neat thing. I also am able to get, this project was developed with one of our business partnerships at Gensler, and so there's an architect at Gensler that worked with me a lot on like helping to understand the process of designing a building and like what goes into it. And so that's how we got things like, let me change my screen to here, where you get things like this language of RFQ, which is a request for qualifications. That's something that our Gensler architect shared with me. And then she comes in and she actually recruits a few people from their offices to come in and work with our students and give them feedback on their designs. They come in for the final critique and ask them questions. And so yeah, it's a really neat opportunity to also bring in experts from the community, and not just their math teacher, and share that work with them, and that gives them a little bit of an edge too. Like I've heard them preparing for presentations where they're like, one of the other projects we do, there's a few Boeing engineers who get to come in, or who we get to come in, and they're like, oh, we have to get this really good because the engineer is totally gonna like call us out on stuff. So it's really a neat thing, and you can kind of see some of the work that students do is pretty amazing, and what they're able to put together. So they build out this cost function, like I said, they find this one's the cylinder one, radius and height. What does that look like? They connect it. It's a magical moment when they put this into Desmos and find that their value is the same or is accurate. This makes grading super fast too. And then, this is one of our really early projects, but this is one that I was using every year as consistently as a model for how to lay out work because she did such a nice job with that. One last thing. So I typically have students, I'll put this up there. You can see mine is not even it's just a strong average week. This is another system we've been toying with. So one of the other things that we do is all of those checkpoints that you saw are turned into Google Classroom. And Google Classroom allows me to give them really quick feedback and on a targeted thing. So instead of getting like a stack of printouts and me like manually circling something and trying to write some like detailed feedback, Google Classroom allows you on the things that the students submit to click on a part that you're concerned about, or put a little box around it, and you type in a comment. And usually it's something that a lot of students have done, so I can copy and paste from like a comment bank that I've developed. So like, if one of the things that they frequently don't do is they just write equal signs, they don't put a C in front. So I'm like, don't forget the C. And then that's something that I can just like copy and paste from all my comments that I've written over the years. So that makes feedback really efficient during checkpoints. It also makes grading really efficient. So when I grade it the same way, they turn in Google Classroom, I fill out this rubric on Microsoft Word, attach it to their Google Classroom post. I'm the only one who gets to see it when it's an assignment turned in. It's not like posted to the class. And that's how they get their grades back and their feedback too. So, and then you can also, so like if there was, a lot of teachers will do like templates for the slides, and they'll create that like on a Google slide or something, and then especially for the early grades it's really helpful for that. So they'll create a template for the slides or create a template for the document, and then you can also push that out through Google Classroom and it'll create one of those files for each student. Auto generates a title, which is great, so you get all the file names are all kind of like organized. So that's another option that's really nice, is that you can push out documents and have them utilize them as well. So that's kind of the quick rundown of, or I guess not so quick, rundown of some of the projects that I've done in teaching math at Da Vinci. The resources that I shared today are all on Google Drive, or I don't know how, I'm going to be uploading those for you all too. So you all should have access to it as well. So thanks so much for the opportunity to share some of my math projects with you, and good luck, everybody.